Hello, class. In section 3.3, we solve systems of equations by graphing. Now we're going to try to solve systems of equations by substitution. Okay, and some of you are already familiar with this technique. Okay, if you look at example 1, right, we have a system of equations, x equals 5 and y equals 2x minus 3. And we could say, all right, let's solve that system by substitution. So to handle this problem, we would, oops, let me just click on my ink. All right, so if I know x equals 5, I can replace x with 5. So I get y equals 2 times 5 minus 3, or y equals 10 minus 3, which is y equals 7. But that's not the answer. When we solve a system of equations, we need an ordered pair, right? So the value of x is 5, and the value of y is 7, okay? So, and then, you could always check your work by putting in 7 for y and 5 for x to see if it works, okay? So this wasn't bad. I didn't really have to do anything with this first equation, right? Let's look at another example. Right, so for this second example, we know y equals -2. So I plug in -2 to y, and I'm left with 2x plus 3 times 2, -2, equals 8. So I'm now left with 2x minus 6 equals 8. I add 6 to both sides, and I'm left with 2x equals 14, divide by 2, and you get x equals 7. Right? And again, the ordered pair would be 7, -2, right? Because we know y equals -2 and x equals 7. All right, so far so good. Let's try another problem. If we look on the next page, all of a sudden, instead of having the variable equal a number, right? If you look at example 3, instead of y equaling 2, we have y equals 2x. So that's a little bit different than what we're used to. So let's try this problem using the same technique. Okay, so if I know y equals 2x, right? Y is equal to 2x. I can rewrite this first equation as 2x plus 3. But instead of writing y, I'm just going to open the parentheses and close parentheses, equals 8. Right? So I wrote everything from this equation except the y. Now, if I know y is equal to 2x, I can replace this y with 2x. So now I'm left with 2x plus 3 times 2x is 6x equals 8. If I combine like terms, I have 8x equals 8, and then we divide everything by 8 to get x equals 1, right? So the ordered pair would be 1, and you know what? We don't know what the y is yet, right? But we know y is equal to 2x. So if I take x equals 1 and plug it back into the x, right? Because if we know x is equal to 1, we can replace x with 1, right? So I can write y equals 2 times 1, which gives us 2, right? So my x is 1 and my y is 2, right? So the ordered pair is 1, 2. Okay? And again, you can check your work, right? Because if you know that this is your x and this is your y, you can plug these values in to both equations to see if they work, right? To make sure everything is true, okay? So now I'm going to jump to a document that I made myself that's outside of the textbook. It looks like this, just kind of to summarize everything. To solve a system of 2 linear equations containing 2 variables by substitution. 1, solve one of the equations for one of the unknowns. Substitute the expression solved for in step 1. Solve the linear equation. Substitute again. Check your answer. Okay, so maybe you want to take a moment to, I don't know, take a screenshot of this, or just jot this down, or take a picture with your phone. But these are good steps to think about. All right. So when I look at this example, example 1, let's get this out of the way. Right, so step 1 says solve one of the equations for one of the unknowns. This is done for us, right? That means you get x by itself or y by itself. So I have x equals negative y plus 3. So I could substitute everything I've just circled into x down here, right? Or, since I know y equals x plus 1, I could substitute x plus 1 into y, right? So either way will work. But I think I'm going to do this, right? So I'm going to say, all right, x equals everything I've just circled, and I'm going to erase the bottom equation with everything I just circled. So I'll rewrite this up here. Y equals, instead of x, I'm going to write open parentheses plus 1. And since I know x is equal to this y, whoa, hold on for a second. Since I know x is equal to this negative y plus 3, I could put in negative y plus 3, okay? Oh, yeah, right? So I have y equals negative y plus 3, and then plus 1, right? Because here's the plus 1. So let's clean this thing up. I'm left with y equals negative y plus 4, right? Because the 3 plus 1 is going to be 4. Then when I add y to both sides, I have 2y equals 4. If I divide by 2, I get y equals 2. So that's just part of my answer, right? That's not the whole answer. I need to get the ordered pair, right? So I know my ordered pair is going to have an x and a y. We know the y is 2. To find x, take y equals 2, and you can plug it in either here or here. It doesn't matter where, right? So I'm going to use the top equation. X equals negative y plus 3. And so, right, since I know what my y is equal to 2, I can plug in 2 here. I get x equals negative 2 plus 3, or x equals 1. So here's my answer, 1 comma negative 2. Okay? I'm going to stop here. In the next video, I want to do maybe 2 or 3 more practice problems, and I think we will have mastered solving systems of equations by substitution. Thank you for watching.